When we wake up in the morning and look out of the window, most of us are greeted by a familiar sight, a bright blue sky. We take it for granted, but why is the sky actually blue? Why not white, black, or even green? At first glance, the sky should be dark. After all, space itself is black. The secret lies in the interaction between sunlight and Earth's atmosphere. White light isn't really white. The sun's light may look plain and white, but in reality it's made up of all the colors of the rainbow. Red, orange, yellow, green, blue, and violet are all present, each with a different wavelength. Red light has long wavelengths. Blue and violet light have short wavelengths. When sunlight enters Earth's atmosphere, it doesn't simply pass straight through. Instead, the light waves collide with gas molecules and particles, bouncing around in different directions. Rayleigh scattering. The key in 1871, British scientist Lord Rayleigh explained this effect, now called Rayleigh scattering. He discovered that shorter wavelengths of light, like blue and violet, scatter much more strongly than longer wavelengths like red and yellow. In fact, blue light scatters about 10 times more than red light. This means that as sunlight travels through the air, the blue and violet portions of light are sent flying across the sky in every direction. When we look up, we see the scattered blue light from all over, not just from the sun's direct path. Why not violet? If violet light scatters even more strongly than blue, why isn't the sky purple? There are two main reasons. Our eyes are less sensitive to violet light. We perceive blue far more strongly. The upper atmosphere absorbs some violet light, especially due to ozone. The combination of physics and biology gives us a sky that appears beautifully blue rather than purple. The sky as a giant diffuser, think of the atmosphere as a gigantic light diffuser. The sun's rays come from one direction, but the molecules of air scatter the shorter wavelengths so that the entire dome above us glows blue. Without this effect, the sky would be as dark as space itself. A long scientific journey, humans have wondered about the sky's color for thousands of years. Ancient Greeks thought it might be caused by reflections of the oceans. It wasn't until the 19th century that science provided the true explanation through Rayleigh's work. Today, we know that the simple blue of the sky is the result of billions of tiny interactions between sunlight and thegases in our atmosphere, a natural phenomenon we see every day, but which is deeply tied to the laws of physics. If the daytime sky is painted in shades of blue, then sunrise and sunset are nature's masterpieces in red, orange, and pink. But why does the same sky change its color so dramatically depending on the time of day? The long journey of sunlight, the answer lies in the path sunlight takes through Earth's atmosphere. When the sun is high overhead at noon, its rays travel a relatively short distance through the air before reaching our eyes. But when the sun is low on the horizon at dawn or dusk, its light must pass through a much longer stretch of atmosphere, several times greater than at midday. This longer journey acts like a filter. The shorter wavelengths, blue and violet, are scattered away so completely that by the time the sunlight reaches us, they're practically gone. What remains are the longer wavelengths, warm reds, oranges, and yellows that dominate the sky. That's why the sun looks golden or red at the horizon, and why the surrounding sky glows with fiery colors. Dust, pollution, and volcanoes. The effect can be amplified by what's floating in the atmosphere. After a volcanic eruption, enormous amounts of ash and aerosols scatter sunlight even more, creating blood-red or even purple skies. The eruption of Krakatoa in 1883, for example, produced sunsets so intense that people around the world thought the heavens were on fire. Desert dust carried across continents can tint the sky yellow or deep orange. In modern cities, air pollution and smog act in a similar way, making sunsets appear more vivid but often with a dull, hazy quality. The blue hour. Right after sunset and just before sunrise, there's a magical period known as the blue hour. During this time, the sun is below the horizon, but its light is still scattering high in the atmosphere. The result is a deep, rich, indigo blue glow that photographers love. It doesn't last long, maybe 20 to 40 minutes, but it gives us one of the most dramatic transitions between night and day. The red-moon connection, the same physics also explains why the moon can appear red. When the moon is low on the horizon, its light travels a long path through Earth's atmosphere, just like the sun, and turns orange or red. During a lunar eclipse, Earth itself blocks direct sunlight, and the only light reaching the moon is bent through Earth's atmosphere. Because blue light is scattered out, the moon glows with a reddish hue, giving rise to the name blood moon. Cultural meaning of red skies. Throughout history, red skies have inspired myths and proverbs. Sailors had a saying, "Red sky at night, sailors delight. Red sky in morning, sailors warning." This folk wisdom has a basis in meteorology. A red sunset can mean dry air is moving in from the west, good weather, while a red sunrise often indicates moisture and storms are on the way. For poets and artists, red skies symbolized passion, endings, and transformation. Even today, no two sunsets are the same. Every one is a unique performance created by the atmosphere, particles, and the angle of sunlight. The fiery colors of sunrise and sunset aren't random. They're the natural result of sunlight taking the long way through the atmosphere. As blue light scatters away, the reds and oranges shine through, turning the sky into a breathtaking canvas that has inspired awe since the dawn of humanity. We've explored why the sky is blue and why it turns red. But what if Earth didn't even have an atmosphere? And what about the skies of other planets? To truly appreciate our world, we need to step outside of it. A sky without atmosphere, the black dome. Imagine standing on Earth with no atmosphere. The sun would blaze as a brilliant, blinding disk in the sky, but all around it would be nothing but pitch-black space, even at noon. No soft blue, no glowing sunsets, no gradual twilight. The stars would be visible in broad daylight, twinkling behind the sun's glare. This is exactly what astronauts see on the moon, which has almost no atmosphere. When Apollo astronauts walked its surface, they described the shocking contrast: a sunlit lunar landscape beneath their feet and a jet-black sky above their heads. It shows us that our blue sky is not the natural state of the universe. It's a fragile gift of Earth's thin, protective shell of air. How weather alters the sky. Our sky is never constant because Earth's atmosphere is alive and moving. On clear days with dry air, Rayleigh scattering creates a rich, vibrant blue dome. When the air is full of water vapor or tiny droplets, light scatters differently, through scattering, giving Thesky a pale, whitish appearance. During storms, thick clouds absorb most sunlight, painting the sky in heavy shades of gray. Rainbows appear when sunlight bends and reflects inside raindrops, splitting the white light back into its rainbow colors. Even subtle changes in air quality can tint the sky. A thin haze can make it silvery. High cirrus clouds can scatter light into glowing halos around the sun. The atmosphere is not just air, it's a dynamic lens constantly reshaping the light above us. Dust, ash, and fire. When Earth itself paints the sky at times, the entire planet becomes an artist. Desert dust blown across oceans can give the sky a golden or reddish tint. Sahara dust regularly drifts into Europe, changing sunsets for weeks. Volcanic eruptions inject ash and sulfur particles high into the stratosphere. The eruption of Krakatoa in 1883 and Pinatubo in 1991 created spectacular sunsets worldwide, with skies glowing crimson and purple long after the sun had set. Wildfires, which are increasing in frequency, can fill the sky with smoke, giving it a coppery glow and turning the sun into a blood-red orb. Nature's power is written across the heavens, and sometimes the most beautiful skies are born from the most destructive events. The impact of humanity, smog and light pollution, we humans also reshape the sky. In megacities, smog from cars and factories fills the atmosphere with fine particles. Instead of clear blue, the sky becomes hazy, yellow, or gray. It's the same scattering physics, but now twisted by pollution. At night, light pollution washes over the darkness. Street lamps, billboards, and skyscrapers send artificial light upward, bouncing it off particles in the air. As a result, city dwellers see only a handful of stars, while in remote places the Milky Way blazes across the sky. Ironically, the very atmosphere that makes life possible is also what reveals our environmental footprint. Skies of other worlds, our sky is just one version of what's possible. Across the solar system, planets and moons offer stunningly different heavens. Mars. With its thin atmosphere full of red dust, Mars often has a salmon-pink sky. Strangely, at sunset, Martian skies can turn blue near the sun, the opposite of Earth's pattern. Venus. A crushing atmosphere of carbon dioxide and sulfuric acid clouds blocks almost all sunlight. The sky there is a murky yellow haze, oppressive and blinding. Titan, Saturn's moon. Titan's thick atmosphere of nitrogen and methane creates an orange sky, darker and heavier than Earth's but still glowing. Gas giants. On Jupiter and Saturn, you wouldn't see a sky at all, but endless layers of swirling clouds, striped in-browns, reds, and whites. Each world has its own version of sky, shaped by gases, chemistry, and sunlight. Earth's vibrant blue is not universal, it's rare and precious. The sky in culture and meaning for thousands of years, humans have looked up and wondered. A blue sky symbolized peace and infinity. Red sunsets inspired myths about gods, omens, and beauty. Even today, painters, poets, and dreamers draw meaning from the shifting colors above. Science explains the physics, but the emotional impact of the sky goes beyond equations. The heavens are both a laboratory of light and a canvas for human imagination. The sky is blue because of Rayleigh scattering. Molecules of air scatter short wavelengths like blue more strongly than long ones like red. At sunrise and sunset, the light's longer journey through the atmosphere scatters the blue away, leaving fiery red sand oranges. Weather, dust, and pollution shift these colors, while other planets reveal skies of pink, yellow, orange, or nothing but black space. Without our atmosphere, there would be no blue dome, no sunsets, no twilight. Just a black void above. Our sky is not just decoration, it's a constant reminder that Earth is unique, alive, and fragile.